Again, good morning, good afternoon, good evening, everybody. Thank you very much for joining the seminar on the survey that we have kicked off for the optical adhesives project. With me here is CTO iNEMI, Grace O'Malley, as well as Dr. Anuradha Agarwal, Director Electronic-Photonics and Packaging for MIT Microphotonics Center. So with that, I would like to hand it over to Grace to kick us off. Grace, please go ahead.
Great. Thank you very much, Girish. I hope everyone can hear me okay, and welcome very much. A great welcome to everyone joining us today. And one of the reasons we wanted to have this webinar was to, I suppose, announce or celebrate the collaboration that we have with MIT under their FUTUR-IC Alliance, which is focused on developing sustainable manufacturing processes of the future. And Anu will talk a little bit later on that particular program. But also it's to celebrate some additional work that iNEMI is doing in the area of optoelectronic systems manufacturing. And I'll talk a little bit, and Girish will take you through that, because the survey which we're launching today is really to get an understanding of what's going on in the industry and what the anticipated needs and requirements to support the development of adhesive interconnect systems for optical and optical electrical systems in the future will be. So if we can move to the next line, or a slide if we could, Girish. My name is Grace O'Malley. I'm the CTO of iNEMI, and thus I'm responsible for the technical activities, primarily the projects that we run, collaborative projects. We presently have 38, either running or in the pipeline at the moment. And these are where industry leaders, members of iNEMI, and key strategic partners come together to address some of the common gaps that are identified in new emerging technologies in terms of manufacturing, or address some of the challenges that we have to moving into high volume manufacturing with new technologies. We also, and probably very well known over the last nearly 30 years, for the road mapping work that we've done in electronics manufacturing. And we continue to do that, although in a slightly more focused and dynamic format than we did in the first 25 years. We now have an online road mapping capability, and that we're constantly updating with new content and technology. Apologies for that. And I think the crux of what iNEMI does, though, is collaboration across the industry. So working together to define what the challenges are in terms of road mapping, the emerging needs, but also bringing project teams together to address those challenges. We have approximately 90 members presently, and if we move to the next slide, I think you'll get a view of who they are and what they represent. And they really represent all aspects and perspectives along the electronics manufacturing supply chain. So from people involved in fabrication of device and components, base material suppliers, leading research institutes, some of the leading industry associations around the world that support electronics manufacturing, and then the traditional cohort of those involved in board assembly and system integration. So this has been a consistent membership. We've some members right from the very beginning 30 years ago, but we consistently have a global, diverse, and very active membership looking to address some of the upcoming challenges that we see in the next sort of 3 to 5 to 10 years in electronics manufacturing, and work together in a pre-competitive space. So in short, why do people get involved with iNEMI? Why do they join? I mentioned the road mapping, which is very important, as it helps get alignment in the industry, not just on the technology needs, but also on the timelines the different applications are going to require the developments for. And then that helps, I think, set the pace and set the, not only set the agenda in terms of the technical challenges, but also set the pace that these need to be developed and who needs to be working working on them. So you'll see as I talk about some of the projects, we have very different outputs and outcomes from the projects that have different impacts on the industry depending on the maturity of the technology areas. The projects are where most of our members contribute all the time. If we can step back, Girish, sorry, to the last slide. Thanks. I talked about the projects and I'll talk about those a little bit more in detail, but I would also like to mention the benefits, as is often the case in being involved in a consortium, is being the access and ability to leverage the iNEMI network. It's always been a very global organization, as electronics manufacturing is, and working together not just on the projects but on the working groups that help identify the challenges and prioritize the work that the industry should be doing, and in particular iNEMI should be doing. It's an opportunity to work with your peers and indeed some of your mentors in the electronics manufacturing, materials development, smart manufacturing and sustainability space across the industry. The next slide, I'll just briefly, you can find lots more information on our website, but just talk a little bit about the iNEMI roadmap. I mentioned we've changed the methodology that we used to put the roadmap together in recent years. So it's now all online, essentially sort of a Wikipedia-like format. So we have working teams working together, developing the content, identifying the key areas that we need to examine and analyze what are going to be the challenges, and creating content, having it reviewed by technical reviewers within the iNEMI ecosystem, and then publishing it. We moved to this methodology a number of years ago because we previously had a 2-year cycle and issued documents that people could download, but in many cases they were nearly out of date by the time we had published them. So this gives us a lot more flexibility and makes it more dynamic, so we can update it much more readily and keep a track of what's going on in the industry, what are the latest trends and changes and indeed inflection points that need to be considered. If we can move to the next slide, please, Girish. We're focused today on optoelectronics and optical packaging in particular, but we do have project areas and activities addressing a number of key strategic areas in the industry. And again, the focus is always on the electronic manufacturing related challenges. So how do we enable high volume manufacturing to support new application spaces or to introduce new technologies? In the link below and on our website, you can access all of our ongoing projects and those that have been completed over the last 10 years. And so you'll get a description of each of the projects, if there's been any publications and presentations given. Those are typically available to the industry at large, with some of them being restricted for members only, primarily based on the recommendations from the member teams. Okay, next slide. As I mentioned, what comes out of an iNEMI project, and that's something we'll consider when we talk about today's survey, is, long ago it used to be a report and that was it, but obviously nowadays we need much I think a higher value expectation in terms of the projects, and also a faster time to implement the results coming out of there. So in many cases it's a lot of data, whether it's characterization data, say to drive manufacturing improvements, to evaluate new methodologies, inspection methodologies, say for higher density substrates, for example, to look at new testing methods. We did a very large program in the last few years on material characterization for 5G, 6G and millimeter wave applications to support obviously the transitioning and advent of new technologies in those areas in the industry. We've done work supporting the increased digitalization of electronics manufacturing and the smart manufacturing ecosystem. And then since the very beginning, we've also had a very strong emphasis on what we used to call environmental electronics, and now comes under the umbrella term sustainability and indeed circularity. So we have many projects looking over the years on optimizing material substitution to, for example, lead-free and halogen-free applications. Also looking at development of tools to support understanding the environmental impact of our manufacturing processes, and different approaches and methodologies that we've looked at over the years are reported on our website. And that's, I think, one of the reasons that we're very interested to work with MIT on this FUTUR-IC Alliance, because I think we bring an understanding of the manufacturing processes and also the sustainability and circularity goals and visions that are required in developing new processes going forward. I'll quickly just highlight some of the larger programs we've had over the last 2 years, which may be of interest. I mentioned the 5G, 6G millimeter wave and characterizing materials, and that's being supported now with the development of standard reference material for the industry. So over 25 organizations worked together to evaluate the existing testing capabilities, evaluate new and emerging capabilities, and give guidelines and references to the industry in terms of the material samples and also best practices in doing the measurements and at particular frequency ranges. Likewise, we have an ongoing project which will finish up now in the first quarter on looking at the impact as we move to higher frequency of copper foil roughness. So not just evaluating the copper foils that are on the market, but also looking at the evaluation methods and inspection methods so that the industry can use to determine and characterize materials that they're looking at. The last example is focused, next slide, please, is focused on some of the optoelectronics work, and we've been doing work in this area over a number of years. And again, the focus of our projects is not to develop new technologies, it's not developing products, but it's supporting the introduction of them into high volume applications or high volume manufacturing processes. So we've done a lot of work with the optical connector space, particularly looking at expanded beam connectors, and now specifically focused on data center applications. And much of that work, which is done, across the iNEMI partnership team, which is about 10 organizations, I believe, at the moment, is being reported to the standards bodies. So that's, again, one of the big impacts that we have now. So, relative to the reports we used just issue in the projects 25 years ago, now we're producing data in a format that can be used by form guidelines to the industry to the relevant authorities and associations, but also provide good technical body of work that can help the faster development and refresh of standards for the industry, which is very important and saves a lot of time. On the right-hand side here, we talk I talk about some of the photonics packaging work that we've done, and this was with the Tyndall Institute in Ireland, where we actually, unusually for us, did a demonstrator project, but it was really to highlight the design challenges and the type of investment and skill sets and knowledge that was going to be needed to address the optical interconnect the systems that are going to be required in the future, pluggable and those. So that's just a snapshot of some of the projects. So hopefully it's given you a good feel for iNEMI. As I say, you can get more information on the website, and hopefully you will also get invites and follow-ups based on this webinar for those of you that are interested in this particular project. And but let me first of all hand over to Anu, who will talk to you about the FUTUR-IC program itself. Thank you.
Great. Can you all hear me?
Yes, we can hear you.
Okay, wonderful. Thank you. Thank you very much. So I'll talk a little bit about our work with iNEMI. First of all, I'm very happy to be partnering with iNEMI on this project, FUTUR-IC. What is FUTUR-IC? It's actually a new program that we started at MIT in collaboration with multiple entities in the US and also outside the US. For example, Tyndall is one of our partners, iNEMI is one of our partners, SEMI is a partner, and several other companies and academic institutions. What are we trying to accomplish? We're trying to build a sustainable microchip industry across the supply chain. And what does it take to do this? It takes good technology. We have to make sure that we stay on that trend towards high performance, that exponential growth of the semiconductor industry that we're so used to, which we call Moore's Law. We'd like to stay on that trend, but we'd like to find more options such as packaging, electronic-photonic packaging options to stay along that path. If you go to the next slide, please. Yeah. In the previous slide, I forgot to say that those links that are there, Girish, those are for the first one is a website, ichem.mit.edu, where you'll find more about FUTUR-IC. And the other one is a YouTube video that we've created that shares what is our whole team's goal in trying to build this FUTUR-IC. How are we thinking about attacking this problem of making this industry, which is so complex, into a sustainable industry? Not just that, how can we set an example in our industry for all other industries such as cement or plastics or other textile industries, etc. So now the next slide, please, Girish. Thanks. Yeah, this is our organizational structure. We have 3 teams, the technology, ecology, and workforce. And I'll say a little bit about why we chose that. You'll see that we have a very lateral and hierarchical structure that's very flexible. We have partners who advise us. We have participants as well. iNEMI is a participant. You'll see that. And we have Bridgewater State University, we have Springfield Technical Community College, Tyndall National Institute as our participants and our partners. The list is growing steadily every day. We have HPE, AIM Photonics, SEMI, Ajinomoto, Cornerstone, Harvard, MRSI, Photon Delta. These are just a few of the partners. Now, what is it that we do with our partners and our participants? We try and identify hotspots that will enable us to find, as a team, a solution to this hotspot such that the next generation of devices that we make, we design for sustainability from the start. So if you go to the next slide, you'll see the participants of this program. This is all within MIT. These are the people who are participating. Linda Molnar here, shown on the top left, is our program director for the NSF project. It's a convergence accelerator project for which we have been tasked to build a sustainable ecosystem in this industry. The next page shows you some of our outside participants. iNEMI is included, SEMI, Tyndall, and so on. So HPE is also a very close partner. We're building this team that is expanding day by day. Why? Because people are understanding that we've really got to set ourselves on this path towards sustainability, and no industry or no company can do it alone. It has to be done as a team. So on the next slide, I'd like to say a bit about our value proposition. Microchips enable modern life. We know that. But, it also pollutes our environment. We know that too. So the key is, if you look at the blue box at the bottom, how can we increase our production efficiency? The first box on the left saying greater than 1 trillion market by 2030, 70% demand increase from 2021. And most of that demand increase is for computers, communications networks, and now, of course, Gen AI. And the third box on the left-hand side, it says, we need 3 million trained personnel, but we have only 2 million today. So we've really got to grow rapidly. So workforce training is important. On the other side, we know that we're polluting our environment with this exponential growth of our market, 150 petawatt hours of energy usage, worsening day by day with Gen AI implementation, 800 million cubic meters of water, and 500 megatons of CO2 equivalent lifetime emissions. And all of this is from 2021. It's getting worse as we move forward. So the key is how can we balance efficiency of production and environmental efficiency. Next slide, please. So we've defined sources of these emissions as Scope 1, Scope 2, and Scope 3. Many of you are probably familiar with this. In the top box, you can see Scope 1, the industry by itself, in its silo, what are its emissions? Then the Scope 2 part, which is in the purple box on the left side, how much electricity are we buying from outside? And what kind of greenhouse gas emissions are associated with that electricity generation? And in the top right here, Scope 3, everything else, right? The transport, the raw materials, everything else that goes into making a product. So once we've defined these, what FUTUR-IC has chartered itself to do is provide an infrastructure for calculating of the emission, all the emissions and reduction. And if you go to the next slide, you'll see that it's not just for one industry, but across the supply chain. Upstream, midstream, and downstream. What are the drivers of pollution? When you're actually designing, when you're manufacturing in a foundry, what about during front-end processing? Downstream, okay, there's a lot of assembly and back-end packaging. What kind of pollutants happen there? What are these drivers? In the next slide, you'll see that the drivers are pretty obvious. One is that there's growth. I'm talking about this exponential growth, as you see on the left-hand side. 590 billion market in 2021 is rising to about $1 trillion in 2030. And most of this growth, as you can see in that middle, in that growth contribution per vertical box, automotive electronics, wireless communication, computing, data storage, these are the places where the growth is happening at a very large pace. Second reason for pollution is this technology growth to advanced nodes, as you can see on the right side of this slide. We're going down, say, from 28 nanometers to 2 nanometers. And as you can see in dark purple and light purple are the emissions from process gases and electricity in kilograms of CO2 equivalent by node size. So you can see that there's a very large increase as you decrease the node size. So in the bottom box, we tried to summarize what can we do as low-hanging fruits to minimize these emissions. Well, first of all, process gas emissions. Advanced nodes are worse in terms of process gas emissions. So why don't we use it only when essential? Also, can we come up with a way to use low global warming potential process gases? Second, the electricity emissions. They're worse when you use copper wires, for example, for communication. So can we move towards photonics for communication and stay with electronics for computation alone? And in red, I've put down there, what we are trying to accomplish here in our team is low PFAS and global warming potential manufacturing, starting from detection, removal, remediation, and ultimately replacement. That's one thing that we're focusing on. But the second bullet there, the electricity emissions and photonics for communication, that's a huge part of what we are trying to build within our team. We have experts who are in photonic integrated circuits who can show how integrated photonic packaging, or what we call co-packaged optics, can bring about sustainability. As we can see in the next slide, where are most of these emissions coming from? The orange box is the biggest, 299 megatons of CO2 equivalent in this orange box says 99% comes from use of sold products. So, of course, we have to design for low energy consumption during use. But yes, there is some benefit to developing green manufacturing processes in that purple box in the middle. And on the left box, securing vendors with decarbonized products. That's a very important part as well. How can we accomplish all of this? What are the solutions? The next slide, please. What we are seeing at FUTUR-IC is, and by the way, we have talked to almost 160 stakeholders in this industry. This is what our phase 1 project was all about. interviewing industry partners, academic partners, and so on, and understanding the pain points, the hotspots, what is needed. And this is what we've come up with. Three main dimensions: technology, ecology, and workforce, as you can see down here. And they're all interrelated. So the objective is to develop components, high performance technology, but while we stay within an ecological or environmental footprint. And to accomplish this, we have workforce that actually is trained not just in STEM, not just in semiconductors, but also in green literacy. So this is a threefold, I would say a three-dimensional optimization problem based on industry feedback. And the last slide, I believe, is there's one more after this to leave you with it, but the sustainability mission we have is in technology, ecology, and workforce. In technology, we're working on electronic photonic components for large data transfer at high speed, so co-packaged optics. And in this comes the optical adhesive study with iNEMI that we're embarking on right now. PFAS-free manufacturing, or low global warming potential manufacturing that we're talking about, and methane gas detection in fabs as well as in the environment. These are three areas that we are focusing on as a FUTUR-IC team. On the ecology side, we're trying to build a accounting system across the supply chain for accurate accounting using life cycle analysis as well as e-liability with Harvard. How can we start with all of our raw material vendors, use a template that is shared by every vendor across the supply chain, and ultimately it's a final product and we know exactly what that carbon footprint of the product is, rather than ascribing blame to scope 1, scope 2, or scope 3. All of them come together in this one single template. In the workforce, we're working very hard to build multiple ways using modern pedagogical methodologies in order to teach people about STEM and semiconductors, but also how to design for sustainability, how to design for manufacturing sustainability, longer life, upgrade, repair, things like this. With boot camps, with problem-based learning, with academies, with videos, with games, and so on. And the last slide I'd like to leave you with is, where are optical adhesives required as we see it in this project? Well, in new passive electronic photonic packaging, or co-packaged optics, where we're trying to leapfrog to greater than 1 terabit per second I/O. This is a complicated chart, so let me start with the left top, co-packaged optics. As I mentioned, our mantra has been photonics for communication and electronics for computation. If you look at the right chart, it shows you that on that orange line at the bottom, it's as you're marching along in time, if you're trying to improve your performance, the thread performance will improve slowly if you do nothing. But if you make heroic efforts and you follow that red line by increasing the number of transistors per chip, and you follow Moore's law, yes, thank you, Girish, those blue crosses are where you will ultimately reach 1.6 terabits per second. However, FUTUR-IC is offering the three ideas at the bottom: flip chip interconnect, printed microreflector, and pluggable optical connectors. Those three pictures that you're seeing at the bottom, and those are the three innovations that we're bringing to the table to leapfrog from one technology all the way to 1.6 terabits per second technology. So this is what we're bringing to the table. In order to make flip chip interconnects or printed microreflectors or pluggable optical connectors possible, we really need optical adhesives that are transparent, that satisfy the thermal requirements, the material requirements, the cost requirements, and high volume manufacturing requirements. So we are looking to iNEMI, to partner with iNEMI and all of you in this cohort of iNEMI to help us move forward on the FUTUR-IC Optical Adhesives project. And with that, I'll hand it over back to you, Girish, Thanks for this opportunity.
Super great. Thanks, Anu. Thanks for the introduction to FUTUR-IC and the alignment with optical adhesives. So in the next few minutes, what I'm going to do is I'm going to provide the project overview, and we'll go through some of the questions that we are asking in the survey. So the folks that are attending this call and the folks that view this recording after the call are able to visualize the kind of questions and the content we are requesting of everybody. So the project itself, as Anu talked and Grace introduced earlier, photonics and co-packaging solutions are expanding. There are many markets like AI and high performance computing that is driving that. In this particular field, optical adhesives and specifically those in photonics are critical enabling components, and we need to have development and understanding of materials, assembly processes, and test methods that are commonly followed across the ecosystem in order for us to deliver high volume manufacturing, in order for us to lower the cost, but do it in an environmentally sustainable way. So that's kind of the overview of the project. So what exactly is the project's scope? So we have a cross-functional team of engineers, scientists, and practitioners from the industry, academy, and research institutes that are collaborating on the project. And you saw Anu talk about several of them within her slides. The primary scope of this particular exercise is to survey companies and individuals who are currently either developing optical adhesives or using optical adhesives, and then identify those that are active in the photonics and other electro-optics applications. We want to be able to develop a knowledge base of the existing materials, of the existing suppliers, and then any assembly characterization and validation, as well as test methodologies that the teams are using, including those that are being used at research and academic institutes, right? We want to be able to then identify the challenges and gaps for high volume, low cost, environmentally sustainable materials so that we can deploy these optical adhesives. And then this activity will also help us identify project scope. So once we identify the challenges and gaps, they turn into opportunities to collaborate together in a project so that then we can actually develop test devices, we can develop test vehicles, and do some material studies and standards development. And Grace showed a couple of examples of such studies that iNEMI does for materials and for processes, and that ultimately lead up into standards development. So this project and topic would be in alignment with that. And then, as Anu talked about, the project will also deliver training content that the researchers and the industry can leverage for sustainable optical system assembly. So that's kind of the primary scope. The secondary scope, of course, is once we identify the test devices and vehicles, we'll have to develop them. Once we develop those vehicles, we will evaluate and characterize representative materials and test methodologies, as well as assembly process variables. And then, as you saw in some of the iNEMI projects, there may be an opportunity to also do package level reliability. All this body of work will lead to content that will be developed into guidelines and best practices that the industry can use. Since the industry academicians will collaborate together, a lot of these projects will deliver guidelines and best practices that the industry can use. And then we can provide content to the standards development teams for test methodologies. And then as with any project that iNEMI and the other institutes such as FUTUR-IC do, will publish results on a regular cadence, either through webinars here or at different conferences and events. So that's kind of the introduction to the project, and more specifically what is happening with the adhesives requirement for optical packaging. So in the next few slides, I'm going to now talk about the specific survey. In the invite of the registration, you will have seen the survey link. As a follow-up, we will provide the survey link after the event to the attendees as well. So please take some time to help us address the questions we are trying to gather. So what are those questions? So we'll start with the introduction. There is a link to the FUTUR-IC website that Anu talked about. We just want to point out that you can participate in this survey either by identifying yourself, or you can remain anonymous. Only our team members will have access to your responses and or your contact information should you choose to provide it. Folks that provide contact information will be invited to a webinar that summarizes these surveys somewhere around in February of 2025. Of course, if some of you would like to know more about the results of the survey a little earlier, or would like to join the project, please reach out to any of us, and we'll be more than happy to help you with that. The deadline for submitting the survey is January 9th. So there is ample time to think and respond. So please do your best to respond to the survey. So some of the questions we will ask would be about your role in your organization, and it will allow you to choose multiple roles if that is the case. The target markets that you are addressing, either as a service provider, a research institute, a material supplier, or any other type of organization. What is the device level application? You will see in the survey that while the focus is on photonics, we have included several other areas where optical adhesives are used, right? So anybody that is participating in the survey and these projects may be able to leverage the outcome of the projects for their applications, even though if they are not in photonics. Ultimately, we are looking for sustainable materials for optical adhesives. So that's really the idea, right? So question 5 will allow you to do that. 6 and 7 are mandatory questions. We would request you to please address them. So they will allow you to choose the most important considerations when you choose an optical adhesives. And then question 7 will request some additional time from you. We sincerely hope that you choose option 1, yes, and then help us address some of the deep dives on the questions we are asking. So if you do answer it as option yes, which I hope you all will do, you will see several of these questions that go between optical transmission, curing properties, environmental performance, sustainability, assembly, other considerations, inspection, and an ability for you to add things that we did not capture. When you help us rank uh, between A to 16, you will be able to choose the ranking of the options that we have added. There is a box for you to add a new item that we may have missed, and if you would like to skip an option, you can skip by checking in an A box, and it will still allow you to rank the rest of the items the way you want that ranking to be. So we hope that you take this portion of the survey and give us a deeper insight into how you look at optical adhesives. Um, if of course you choose the option no, then you will skip and go to question 18, and it will ask you about product carbon footprint. In addition to that, we will request you to help us identify the test methods and standards that you are using for optical adhesives. If you are using a custom or a proprietary method, you may be able to indicate it as custom. And of course, if you don't test for a particular characteristics, you can choose any. Please, if you do use a custom test, we will provide you the option to allow us to understand if you are willing to share that custom test, so that it can maybe become a consideration for an industry standard. And we encourage you to share, if possible, your custom standards, because the market for optical adhesives is growing, whether you manufacture it, whether you sell it, or whether you use it ultimately in your factories or in your product. So please help us address the standards and the test portions. In on that side, you'll see the different tests. you'll see an empty box. We request you to please type in the test standard that you use in this area, and then that will help us all kind of take a look at the results. Once we go through those questions, you will come towards the end of the survey. We will again ask for information if you want to provide it. If you have not already done so towards the beginning of the survey, now here's your chance. You were really happy with the questions of the survey. You really feel that you are motivated now to understand how the survey results are from the rest of the industry. Please give us your contact information. From 27 to 30, we are asking you how you can contribute or participate, right? Do you offer any adhesives for commercial sale? Do you develop specific workforce development programs? Are you interested to participate and present a seminar on the optical adhesives for these applications? And through the FUTUR-IC network, we regularly invite industry leaders in order to do that. So this is your opportunity to share some of the great work you are doing. And then finally, if you would like to take a particular topic and get a workshop done, then that's something we can collaborate on, where we can put together a workshop jointly with you. We can invite industry participants, and that way we can kind of grow the mutual understanding and help us develop opportunities to solve problems together. So those will be in summary the net questions that you will be asked. In addition to that, towards the end of the survey, you will find information about a green skills study that the MIT team is developing. It will give you information about the inaugural class that is being developed by the team. And then this is some of the involvement if you choose to provide your contact information for this portion of the study as well. So there will be some engagement with the MIT team, and you'll be able to take a comprehensive green skills training program. So if you choose to provide your contact information in this section, you may be contacted by the MIT team in order to explore additional steps for this particular piece. So with that, we'd like to thank you for your attendance. Before we close, I would like to acknowledge a couple of folks that helped us with developing the survey. So Cynthia Williams from iNEMI and Pradnya Nagarkar from the MIT team. They contributed towards putting the survey together and helping us structure this webinar. So we are really thankful for their contributions. Grace? Do we have any questions that are being asked?
Yeah, we do. And let me call the first one out is, do reduced temperature assembly processes such as curing, hybrid bonding, soldering, as such, fall inside the interests of FUTUR-IC? So low temperature assembly processes, essentially.
Can I take a crack at that?
Yeah, sure.
Thank you. Thank you for that question. Yes, absolutely. Because when you're trying to do a combined electronic-photonic connection, make it simultaneously, you do need to have low temperature possibilities so that you can do, you have solders on the package that you have to worry about.
Yes, and a very good point, Anu, because in addition, many, particularly if we talk about photonic modules, they are going to have to be assembled subsequently as well onto, into a system, onto another board or whatever. So, we are looking, while we're focusing on kind of individual interconnect systems right now, it's important to understand the whole system approach that may be required, right? And obviously moving to reduced temperatures in general is, from a sustainability point of view, everything else being equal, is a good thing. So it definitely falls within the scope, I think, of this of the overall program, and will be discussed in this project as well.
So great. So add to that, low temperature as well as high temperature, both are of interest, right?
Yeah, indeed. From a reliability and perspective, also very much of interest. Yeah. We
And the
did have another
survey,
question. Oh, yeah. Sorry. Go
yeah,
ahead.
yeah, no, and the survey has several other boxes for you to provide this input into the survey also. So I would encourage the person that asked the question to please include this comment in the response. Thank you. Go ahead, Grace.
Yeah, excellent. The next question, and perhaps if the person who submitted it wants to unmute and maybe comment on it, I think that would be useful, because it's, does the concept of materials as a service also fall inside the interests of FUTUR-IC? So I think taking reusability perhaps and recyclability to the next step in terms of materials might be something that's for consideration there. But I don't know if the person who submitted it wants to comment further. I'll see if I can open up.
So while you're trying to open that up, I can take a quick shot at an answer.
Sure.
Thank you for that question, Andy. Yes, the concept of materials as a service falls inside the interest. Why? Because if you think about it, we're trying to go across the entire semiconductor supply chain, and it's all starting from raw materials, including extraction and creation of the material. If you have a process in which you can design knowing what the material is ahead of time, and the materials can be provided as a service for that particular application, if that's the question you're asking, then yes, absolutely.
Yeah, that's really about it. And you mentioned PFAS as well. You didn't include recyclability in those, in some of those seal applications, and the potential is that you can contain the PFAS, the amount in the ecosystem, simply from simply by recycling the materials.
Yes. I absolutely upgrade, reuse. We always start with the 3 R's: reduce, reuse, recycle. But we've also added to that repair and upgrade because of it being electronics.
And Andy, we have that called out specifically in the survey. So when you go to the environmental portion, you will see we are asking for repair, we are asking for recycling, we are asking for recovery, and so on and so forth. Thank you for the question.
Great, thank you.
Great, thank you very much. Again, anyone who wants to submit a question, there's a Q&A button at the top. You can certainly do that. I think they'll still be available to us after today's presentation. I don't think you can do it on chat. So if you think of something a little later, feel free. You have our contact details, certainly Girish and mine, for more information, for any assistance with the survey, which you are welcome to send, to your network or colleagues who may be able to contribute as well. Because I think the objective here really is to get a very good snapshot of where optical adhesives development and use is right now, and where we anticipate it being in terms of application spaces and requirements. So certainly having the views of those involved in both the manufacture of optical adhesives, the testing of them, the qualification, looking at the compliance issues associated with them, as well as looking at the new optical applications coming at a packaging level and an optical system level. All of those are very useful perspectives that hopefully we will capture within the survey. And I think Girish will let you know we do have some follow-ups. We will have a webinar. We're scheduling right now for February for that. So you're welcome to come back. It will be advertised on the iNEMI website, but if you include your contact information, then you'll be added to the distribution list, and any updates arising from this project and the FUTUR-IC Alliance as well, we'll share that mailing list with them as we indicated. Okay. Great. I didn't see any other questions come in, so I think, Girish, we're probably ready to wrap up.
Okay, great. Thank you. Thank you, Grace. Thank you, Anu, and thank you all the attendees, the folks that stayed throughout, as well as those that joined. Thanks for your questions, and please help us respond to the survey. Please share the survey links with your colleagues so we can get more input from the industry into these interesting projects that the teams are developing. Thanks again, and have a great rest of the day.